Welcome to a brand new episode of Machine Learning Made Simple. Here we unravel the enchantment behind machine learning, demystifying all the technical jargon. I'm your host, Shogato, and I'm here to chat with you about the revolutionary changes unfolding right before our eyes in the tech world. Let's dive in. Welcome to our final episode of the year as we bid farewell to another incredible year in the world of AI and machine learning. We want to take a moment to express our heartfelt gratitude to each and every one of you who has joined us on this journey. Wishing you all a joyous holiday season filled with love, laughter, and all your favorite things. Now, as we look back at the past 12 months, it's hard to believe how far the entire technology landscape has changed. From the early days of neural networks to the current era of AI/ML, it has been a wild ride and it's continuing. We have seen some technological advances that were once considered science fiction and it has become a reality. The Optimus robots, the humanoid robots are interacting with us like human beings, and we're excited to share some of those highlights with you today. But before we get into the big picture, let's take a moment to appreciate the incredible work being done in this field, from the researchers pushing the boundaries of what's possible to the companies harnessing the AI and ML for the real world impact. It's clear that this community is driven by passion and dedication. One of the most remarkable achievements of the past year has been OpenAI's GPT-4 set of models, and these language models have set a new standard for natural language processing, human interactions, and with their ability to understand and generate human-like language and making them an invaluable tool for a wide range of applications. In fact, probably all of us use ChatGPT at least 2 or 3 times a day. From chatbots that can have real conversation to text summarizers that can condense hours of content into seconds, GPT-4 is totally has rewritten the rules. But what makes GPT-4 so remarkable? For starters, it got an impressive 1.2 trillion parameters, making it one of the largest language models ever developed. That's a whole lot of computing power, and let me tell you, it's paying off in spades. From text generation to sentiment analysis, from tool use to image generation, GPT-4 is opening up possibilities for business and individuals alike. And if that wasn't enough, Meta has released its latest set of Llama 3 models, and these are massive models, the largest open source models that were ever released, with 405 billion parameters. Talk about a friendly competition. But let's be real, folks, OpenAI's GPT-4 is still the greatest here. It set the bar so high and now everyone else is trying to catch up. Anthropic is coming close, but it still has a lot to catch up. Anthropic is just slightly marginally better than GPT-4 in code generation, but it is catching up in other avenues as well, especially script generation. But AI and ML are just not limited to language processing. We have also seen remarkable breakthroughs in image generations from Flux, from Black Forest Labs, which has achieved unparalleled success in the text-to-image game. Previously, it was Stable Diffusions, but then Stable Diffusion had those extra limbs that were generated and extra fingers. So those anatomical issues were completely solved with this new model, Flux, and it has totally blown everything out of the water. And what's more exciting is that this technology is now being used to generate high-quality videos too. We'll talk about that in detail in the main segment of the podcast. So in addition to these technological advancements, we also have seen something known as agentic workflows, which is sweeping all the enterprise architectures in all the big companies where they use large language model operations. So we have migrated from DevOps to machine learning ops, ML ops, now to LLM ops, and they are now implementing this agentic workflows where a group of AI agents work in tandem to solve tiny little tasks, like tiny little workhorses, and they completely finish the whole project. So one part of agent can do like research, and one agent can do text summarization, and one agent can write a report, and one agent can generate the PDF report. So all those things can happen in tandem or in separate unsynchronized fashion, and this is amazing and we'll talk about more with the AI AI agentic in future episodes, but for now I'll just mention the agentic workflow is truly sweeping the enterprise LLM ops. And as we look ahead to 2025, it's clear that AI and ML will continue to play an increasingly important role in our lives. From virtual assistants to self-driving cars, the technologies are totally transforming the way we live and work. And as we explore the possibilities of what next, it's exciting to think that about all the ways we'll be able to harness the power of the AI and machine learning to make a positive impact on the world. So as we wrap up this final episode of the year, we want to take a moment to thank each and every one of you for joining us in this journey. We're grateful for your support. In this special episode, we'll be taking a deep dive into the biggest news, trends, and events of 2024 that happened in this year in 2024. From GPT-4's groundbreaking 4.0 models to the robotics of the Optimus robots from Tesla, we'll cover it all. So buckle up and get ready for our annual recap and join us as we explore the most significant developments in AI and set the stage for an exciting year ahead. Let's start with January of 2024. In this month, Rabbit Tech introduced a simple yet impactful voiced interactive device called Rabbit R1, which demonstrated a remarkable capability to perform voice activated tasks. And people were very excited when this was showcased at the expo, at the AI Expo at Las Vegas. So this device essentially allowed users to use voice commands to order an Uber, book a flight, things like that. So these were seamlessly processed in the backend through a connection to the OpenAI's GPT model. So this innovation wasn't in its complexity, but it also has practicality. Rabbit Tech showed that how cutting-edge language models can be integrated into everyday tools, essentially have a hands-free device at our disposal. But this was maybe slightly too ahead of the curve. Maybe when people started developing the Uber technology before Uber actually came in, they couldn't get on the ground because the technology was like slightly ahead of what might be feasible at that point. So Rabbit R1 is probably too ahead of its time. So that's why it kind of still fizzled out. It's still going, but it's still kind of fizzled out. But the whole point is that they focused on simplicity, functionality, and they really highlighted the power of leveraging existing AI capabilities in new and creative ways. So this was not about reinventing the wheel. It was adding new technology, showing what is possible. So January literally set the stage for a year where the practical applications of AI took center stage, and it showed that even straightforward implementation can have a meaningful impact. So let's move on to February and see how the advancements continued. Let's move on to February of 2024. In this month, Google made headlines with the limited beta release of Gemini 1.5, their latest iteration of large language model, and it was nothing short of impressive. Gemini 1.5 introduced the ability to handle very large context lengths up to almost 1 million tokens. To put that in perspective, this means it can process and maintain understanding over conversations or data sets as long as an entire book, a full 300-page book. For developers, this just wasn't an improvement, it was a game changer. It opened up possibilities for more complex, nuanced, and context-aware applications. And if you have dabbled in this, you will realize the main issue with using large language models in applications, in commercial applications or even enterprise applications, is that it tends to forget after some time and starts hallucinating. So if we give it a lot of feedback, so if it's generating code and it's generating long version, a lot of code, then it might start forgetting what it has generated earlier and then start hallucinating and making things up. And if it's definitely writing long script after, let's say, 5,000, 10,000 words, it will definitely start forgetting everything. for the other language models. Now with these new large language models, where they have so many tokens that's available, their memory is so big that they can keep writing and remember what they have written before. This release wasn't just about flexing their computational capabilities. Google wanted to emphasize the practical applications of Gemini 1.5 and showcase how it could elevate customer support system and generate detailed, personalized content and enhance research workflows. It marked a significant step towards making the large language models more versatile and more useful across industries. In fact, later we'll see Gemini leverages this to release MedGemini, which is trained on medical data. So it was a game changer, and we'll talk about MedGemini later. So what really got the tech world talking though was how Gemini 1.5 positioned itself as a direct competitor to OpenAI's GPT-4. With its focus on efficiency, scalability, and performance, Google was sending a clear message. The race to dominate the AI landscape in 2024 was well underway. So they are trying to take the game from OpenAI. They are slightly behind, but they are catching up really fast. So February was a pivotal month for Google when they showed that how AI can push the limits, the boundaries of natural language understanding with more context-aware capabilities and larger memory. So next up in March, there are more breakthroughs in creative AI applications. Let's talk about that. Let's dive into March of 2024, where creativity and innovation took center stage with Stability AI's release of their new Stable Diffusion 3. Stable Diffusion 3 was a significant leap towards text-to-image generation technology, and they totally took a new direction. It built on their predecessor, which was Stable Diffusion 2 and 2.5. This model showcased remarkable improvements in detail, diversity, and overall image quality. Artists, developers were very impressed with his ability to generate intricate visuals that captured complex prompts with stunning accuracy. So what made Stable Diffusion stand out was not just its technical enhancements, it was the accessibility it offered. Stability AI continues its commitment to open source development, and it ensured that creators worldwide could leverage its cutting edge technology without barriers. So they allowed anyone with a revenue less than $1 million a year to use these models for free. And then everything took off. So if you are familiar with Comfy UI, you can totally change the way you use these models. The release also sparked conversations about the broader implication of AI in creative fields. With tools like Stable Diffusion 3, the line between human and machine-generated art grew increasingly blurred. And this was not just about generating pretty picture, it was about unlocking new areas of artistic exploration and redefining creativity with these new AI tools. So this was an innovation in its own right. It was a landmark event, and in March this was totally changed the landscape, and the innovations that started happening after this came in very quick succession. In fact, starting from March till the entire summer was a flurry of new text-to-image generation models that were continuously deployed, and if you were following the news, it was kind of a whirlwind, and it was almost impossible to keep up with these AI models, the new image models that are being released almost every day, some even like 2 or 3 in a day, and it was mind-numbing. But any of you who has kept up with that, it's like kudos to you. This was a great time. The summer of 2024 was a great time for the text-to-image models. So many variations on top of the Stable Diffusion model came out. So next we'll head into April, where breakthroughs in healthcare and open source tools took the spotlight. Let's talk about that. April of 2024 brought some of the most transformative developments in AI, spanning open source tools, cutting-edge neural architectures, and groundbreaking medical applications. Let's unpack this extraordinary month. So let's start with the Devika. Stitching AI made waves with the release of Devika, an open source AI-driven code generation tool inspired by Devin, its proprietary counterpart. Unlike traditional code generation models, Devika implemented agentic workflows allowing it not only to generate code but also break down high-level tasks into manageable components, research solutions, and executive iterative improvements autonomously. So Devika's focus was on accessibility and collaboration and leveraging its open source nature to build a community of developers who are pushing these tools' boundaries. However, while Devika showed considerable promise, it struggled to keep up with the highly advanced and fine-tuned systems that Anthropic developed and eventually Cursor brought into their own IDE. Cursor is an IDE code generation tool that people are using now to perform code generation, which boasted superior reasoning capabilities and adaptability. So Devika really lagged behind, and I think since the release of Cursor, the open source community has kind of moved away and looking at other things. Still, for an open source initiative, Devika's role in fostering the innovation and the inclusivity couldn't be understated. One of the most significant AI releases of this year was Meta's Llama 3, a multilingual large language model that quickly became the centerpiece of the open source revolution in AI research and development. Llama 3 took major strides with it has had an 128,000 token context window, one of the most largest context window that's out there on par with the proprietary and commercial Anthropic's Claude series of models. And the largest model Llama 3 Meta released was the Llama 3 405 billion. This is one of the largest open source model free to use models ever released for the public. Unfortunately, that is also too big for commercial, for consumer use, so they cannot run it on. So they developed a smaller models, which are the 70 billion model, and then there is a distilled 8 billion model, Instruct model, that they distilled and fine-tuned from those bigger models. So the training is slightly different for those 8 billion and 70 billion models. They are kind of trained differently from the 405 billion models. So 405 billion models output is almost at par with the GPT 3.5 and also sometimes GPT-4 models. So unlike its predecessors, Llama 3 wasn't limited to text processing. They added this multimodality into this. So this is the first open source fully multimodal model with a large context length. It can generate, understand contexts and generate responses with highly detailed and long form prompts, and it made it invaluable for complex research, document analysis, and creative writing. It wasn't just limited to text processing, and it has full multimodality. It has multimodal functionality, which is still embedded in it. It demonstrated its potential to process images, videos, everything alongside text. The model was trained on a vastly expanded data set. Now the model training was different for the large model, 405 billion model, 70 billion model, and 8 billion model. They have different training data sets, but that being said, they still have the access to the quality data sets. So the data sets are much improved, much better, with much less bias and better human feedback. And that resulted in substantial improvement in its code generation, language translation, and the problem solving abilities. So what set Llama 3 apart was its accessibility. By continuing its open source philosophy, Meta ensured that researchers, developers, and startups could leverage this state-of-the-art model without the prohibitive cost associated with the closed systems. It represented a huge step forward for open collaboration in the AI community, and this doesn't stop there. In fact, Meta goes on to release better versions, more fine-tuned multimodal versions of Llama 3, and we'll talk about this when we talk about that in the future segments in the coming months. April also saw a groundbreaking advancement in neural network architecture with the Kolmogorov-Arnold networks, CANs for short. So these are introduced by one of the researchers was the cosmologist Max Tegmark. These networks mark a departure from the traditional deep neural networks, which rely on linear weights. Instead, CANs utilize polynomial functions of weights and biases, which allows them to solve complex equations with a level of precision and efficiency that linear-based systems can struggle to achieve. So for example, it can solve calculus problems which linear models have to actually memorize. They cannot really solve it. So the CAN's design takes inspiration from the Kolmogorov-Arnold theorem, which proposes that any multivariate function can be represented as a sum of univariate functions and their interactions. So we'll not go into detail, we already talked about this. So this architecture can unlock, since it is so complex, and since it has such nonlinear interactions, it could unlock revolutionary applications in physics, mathematics, and all of those technical fields where modeling nonlinear relationship is critical. As Tegmark explained in the paper, CAN represents an exciting evolution in how neural networks can simulate and integrate real-world problems. Now, we also talked about the Gemini models. Now, the whole point of the Gemini model was to come up and make it more flexible and apply in diverse fields like medicine. So Google came up with this MedGemini set of models, which is a specialized AI system designed to enhance medical diagnostics and reporting. MedGemini broke new ground by not only identifying the patterns in X-rays and MRIs, but also offering context-aware diagnosis. So in fact, if we just upload an X-ray of a lung, it can see what's going on and say if there is a broken rib or something. It can also identify tumors from the X-ray, and it gives the proper report that a proper X-ray technician would provide. It could read scans, interpret anomalies, and generate all those detailed medical reports, complete with explanation and treatment suggestions. So what set MedGemini apart was its ability to integrate seamlessly into clinical workflows. In fact, they are trying to do it now. They are implementing MedGemini everywhere. Doctors could use this model to cross-check their findings or handle cases that require rapid turnaround times. And beyond radiology, the model showed potential in pathology and even genetic analysis. Points to a future where AI could be a vital collaborator in medicine, rather than just a tool. So MedGemini is totally reshaping the medical and healthcare field. And if you're interested, if you're in medicine, if you're in healthcare, you should definitely look up MedGemini and its capability. April of 2024, it was really a month where AI really shined. It revolutionized multiple domains simultaneously, from Meta's commitment to open source, Llama 3 to the Khans to MedGemini that impacted the healthcare diagnostic. April was a testament to AI's limitless potential. As we look ahead, May will bring us conversations about generative AI and groundbreaking policy decisions that will shape the future of artificial intelligence. Let's talk about that next. May of 2024 was the month that transformed our digital landscape forever. It ushered in a new era of AI-generated images and text, starting with GPT-4 to all the new stable diffusion variation of the stable diffusion models. So let's start with the stable diffusion models and the image generation, and that wreaked havoc and totally changed the way that we look at AI generated content. So let's talk about the Met Gala photos that dominated the social media. Katy Perry and Rihanna appeared in stunning images that went viral instantly. But here's this twist. Neither of them attended the Met Gala event. These images were entirely AI generated with such unprecedented realism that even seasoned photographers initially couldn't decipher them as fake. Both the celebrities had to come on social media to confirm that these were fake AI generated images and they were not actually present at Met Gala. They never attended the Met Gala. So this wasn't merely another technological advancement. This was the culmination of Ian Goodfellow's visionary work with the general adversarial networks, where he envisioned that at some point it will be difficult to distinguish AI-generated images from real images, and that was the GAN network is all about. You have a discriminator which tries to discriminate the generated images and label it as fake or real, and there is a generator which tries to trick the discriminator. Finally, we have arrived at it. We didn't use the GAN network because the GAN network requires the power that we didn't have then, but we used a different diffusion method to reach that potential. The distinction between authentic and artificial content simply has ceased to exist, and that caused a huge stir across the globe. Governments launched intermediate actions, implementing regulations requiring watermarks and digital identifiers on AI-generated images, because the scope for misinformation and disinformation is so large for this AI-generated content that it sparked an intense debate about the trust in visual media, about the accountability in AI development, and the prevention of technological exploitation for the disinformation. And meanwhile, the Hollywood artists, they are also started coming out and saying that their likeness could not be used for AI-generated images, AI-generated content, and other AI generated creative media. So that added another layer to this technological revolution. Artists initiated legal proceedings against AI companies over the unauthorized use of their work. These painters, all of this said that their work has been used for training the large language model without their permission, and this really started the conversation about what is right and where to draw the line. Should we draw the line that we should not be using AI generated images in the likeness of an actor, or should we seek permission? Like will.i.am, he totally patented his virtual avatar and he actually licensed it out, and is that okay to his avatar, AI generated avatar, and not someone else's like Katy Perry, because they have not expressly granted their authorization? So where do you draw the line? Can we use Tom Hanks' likeness to generate videos where he teaches moral values to other people or to children? Can we generate those videos? Because that likeness is liked by everyone. Tom Hanks is liked by everyone. So now if Tom Hanks do give the permission, can we use that? In fact, some people did that, but he didn't give the permission. So he had to go and sue them to have them take that content down. And all those created a lot of complications around this, because there are no robust rules and regulations and laws around this. And frankly, the lawmakers cannot catch up with the speed of development in the AI generated content area. The existing framework simply wasn't built for a world where machines could replicate artistic styles with perfect precision. It came in too fast, too hot, and the regulators simply couldn't have the time to respond. Although EU did respond quickly with regulations of their own, which we'll talk later about. The legal system did respond with some speed. New copyright regulations were introduced. The concept of AI assisted works as a distinct category was introduced, and that required explicit attribution of both human and AI contributions. Now there is a catch though. If we use some template for someone else to generate an image, that's not our own. But if we can tweak the parameters, for example, if we are using the stable diffusion model, there is a parameter called DDPM plus or Keras. If we change those, if we change the way the training happens, how many steps the training happens, so those things can be copyrighted. And it's very nuanced. It's still in early stages yet. But if we use someone else's and copy their settings and generate those images, just having unique prompts is not going to cut it to claim as a copyright. For example, I can say that generate a bird, a beautiful peacock-like bird on a planet like Titan, looking at the bigger planet of which it's the moon. So now it generates some image, and if I use some stock parameters that came pre-built with the model, then of course that cannot be copyrighted. But if I tweak it, if I change the parameters, which of course almost everyone does at some point, then that image becomes copyrightable. And that's a fine line that should be navigated while sitting down with a copyright lawyer who is well versed in this AI copyright laws, which are coming into foray right now. But looking ahead, we are likely to see the emergence of a hybrid copyright framework. This new system will need to balance protecting human creativity with fostering AI innovation, because if there are too many regulations, it will totally throttle any kind of AI evolution, innovation and evolution of those creative works that's going on in AI in US and other countries which don't have those restrictive legal regulations. We're already seeing proposals for dynamic licensing models where AI systems automatically track and compensate artists when their styles influence the generated works. Some experts predict the rise of creative collaborations, and I'm seeing some artists using AI to generate their content, their own artistic visual ideas, and these artists are actively partnering with the AI systems, and then they're sharing rights and revenues in novel ways. So let's move away from this, because there are more to talk about this AI content generation, text to image generation in the coming months. There was a flurry of activity, and we'll touch upon this again, but we'll just stop here and move on to the next groundbreaking development that came from OpenAI with the release of GPT-4o in the month of May. And this was a true astounding development. There is a massive development differences between GPT-4 and GPT-4o. Anyone who has used the GPT-4o model and with GPT-4, they can tell there is a difference. There is a reasoning difference. There is a multimodal multimodality difference. The true innovation lies in its comprehensive integration capabilities. Think of it as a unified AI platform. Seamless DALL-E integration. DALL-E is used for image generation, built-in Python interpretation for data analysis, where you ask it to write a Python code and it will write the Python code. Not only will it write the Python code like GPT-4 did, it can also execute the Python code and can generate graphs, tables, plots, whatever you need for it. So especially if you upload, let's say, a CSV file or any of, let's say, an Excel table or whatever table data set you have, you upload it and it's like, hey, plot this. It will automatically generate the Python code needed to plot it with the most effective visualization and plot it and give it to you. What I find very interesting is I had to take courses in data visualization, and people find it boring, but it's very necessary because many people don't know how to present data correctly in a graph, and it's most of the time it's make or break when presenting data, because data presented in the right light can be very, very energizing, and whoever looking at it making the right decisions. But if the data is represented poorly, with someone uses stacked bar graph instead of pie charts, that might totally make people miss the point and not have them understand the main point of the data set. So in order to distill the data set's true essence into a plot, people do need to take a course in data visualization, but no more. GPT-4 can help us with that. If people doesn't know how to do proper data visualization, all they have to do is upload the data and ask GPT-4 to plot it. And that's a wonderful achievement of GPT-4o, because we don't have to spend 3 or 4 months learning visualization, data visualization. Although I do recommend it because that's an important skill set for any data scientist or aspiring data scientist to have. So GPT-4 also introduced features that redefined what we thought is possible in an AI interaction. It had advanced semantic understanding, which allowed it to maintain context across days-long conversations, effectively remembering and building upon previous interactions. The model's multimodal capabilities are also something to talk about. It has new integration into multimodal capabilities. By multimodal capability, we mean that it can interact with images, it can interact with videos, it can interact with text, it can analyze and generate audio, even process complex mathematical equations in real time. In fact, GPT-4o can take in equations and send it to Mathematica if it cannot solve it myself. Sometimes it can solve it itself. It can solve simple calculus problems itself, but just by running my Python code, SymPy, it runs SymPy in the background. But if it cannot solve it itself, it sends it to Mathematica and solves it. So essentially tool calling. Tool calling is embedded into GPT-4o very clearly, and it even understands and explains, integrate scientific diagrams. So that I found very exciting, because I can upload a flowchart and it can explain in detail the scientific flowchart, and a Llama 3 vision model can also do that, but it's slightly behind than GPT-4o's capability. So this GPT-4 system's problem solving capability are particularly impressive. It can break down complex tasks into manageable steps, suggest multiple approaches, and adapt its solutions based on the user feedback. And for developers, it offers real-time code generation and with integrated testing and debugging capabilities. So that's more pro version. You need to have a pro version in order to do that. So if you're doing code generation, I recommend sticking with Anthropic, which has better code generation capability currently. But GPT-4o did bring in the code generation capability, but Anthropic is really ahead of it right now. But perhaps the most revolutionary is its ability to learn from user interactions in real time within ethical boundaries. Of course, while it doesn't retain personal information, it does adapt its communication style and problem-solving approaches based on user preferences during each session. This creates a truly personalized AI assistant that becomes more effective the longer you work with it. For example, once in one chat message, I told him, hey, I had a PhD in astrophysics, and it remembered it. And when I was like fine-tuning my resume at a later date, maybe 3 or 4 months later, it suggested, given your background in physics, maybe you can write down your expertise in data science and data analysis, that you did as while you're doing your PhD in astrophysics. So it remembered that, and that really creates a personalized experience that people will really like. So Anthropic is different. Anthropic doesn't have that long-term memory, but it has a massive context length. So if it can ingest a lot of data and it can generate a lot of data at the same time, but it doesn't have this long-term memory that it can store over time. There's good and bad. Some people like privacy, think this is a privacy issue. The large language model should not fine-tune our personal aspects of our life. But guess what? If any of us are using any of these models that are hosted in the cloud, we have already shared information that they have already formed personality metrics about us and has enough knowledge about our personalization and behavior, has enough information about us, so we cannot do anything about it. So we can stop using it and ask them to delete our data if we are concerned about privacy, and start using local models. If we have a large enough consumer size GPU, then we can use those. But if we are using those enterprise models, then privacy is really not guaranteed. So now we stand at a critical juncture in a technological history. We are confronting AI systems that can create indistinguishable reality, challenge traditional creative rights, and revolutionize our work process. This isn't just adapting to future technology anymore. It's about navigating our new reality where the previously impossible has become routine. And many people have not caught up. Many people are not using AI content generation. Many people are not using ChatGPT. But those people will at some point catch up. But this has become the new realities. The early adopters have already realized this, and they're already drowning in the sea of new AI innovations. Like I'm drowning in the sea of AI innovation. There's so much tools to learn almost every week. There's not enough time, and hence this podcast, I assume, will help people like me who are drowning in all the deluge of information and extra information that will, and I assume this podcast will cut through all that and just give you the filtered down, whittled down version of the nectar, the honey of the real AI innovation that we really need to focus on, and not worry about the extra noise out there. Because for every vision model that comes out, people create like 200 extra vision models around it, which are tiny slight variations. So now if we are not in the field, like, we can get overwhelmed, and that's what this podcast is intended to do: cut through this noise and give you the exact thing that you really need, that will be really helpful for you. And after OpenAI's revolution, just when we thought May 2024 couldn't get more transformative, Google stepped into the spotlight with and sent shockwaves through the tech industry by introducing their image to video model called Veo. They call it the most capable video model generative model. So essentially this model, and when it first started out, now there are like multiple iterations of it, the first model could generate 6 to 10 seconds of video. And if you have used image generation model, you'd realize that's extremely taxing for any processor or any model, because we have to make sure the image is cohesive, that each frame has to be consistent with the previous frame, and that's very hard to control with any image generation model, because in diffusion network, when we generate and we fix the parameters, the same image would be generated over and over again because the same latent values are used. But if we change the latent values by the seed by even by little bit, a totally different image would be generated. So to keep the same image, the same content, but change it slightly to give the impression of motion takes a lot of extra machinery to be incorporated into the diffusion plus transformer architecture. And that was a great breakthrough. This is not GIF where like we stack images after other and generate an impression of motion. These are actual videos. Now they can generate 4K videos now, but when they started they couldn't generate 4K videos. But the first video that they generated was that of a racing car going through a suburban landscape. I'm guessing it was more Koreatown or something. But they redefined what's possible in video generation. Unlike previous text to video tools that struggle with consistency and realism, Veo produce dynamic video content that remains perfectly continuous across every frame. And that's what we are talking about, to maintain that continuity. And it's very hard to maintain that continuity. It's not just a plain vanilla text to image generation model used multiple times, because every time you change the seed by even slightly, you'll get a totally different image. To maintain that continuity, you have to have slight differences in the image to give the give the impression of motion. So now this video could generate everything from product demonstration to educational content, and it was complete with realistic human movements. So the system even understands complex narratives and it can create coherent storylines that unfold exactly as described. And for marketers and content creators, this really meant being able to prototype entire video campaigns in minutes rather than weeks, even months. Sometimes some video campaigns takes months. So these tools weren't just impressive demonstration, they really represented the vision for the future of creative work. Both the Veo and the Imagen 3 integrated seamlessly with the existing professional workflows, and it offered specialized APIs. Now they have specialized APIs for the enterprise applications and have robust content management systems for tracking and organized generation of those assets. So the timing of these releases proved particularly significant as they coincided with a landmark moment in AI regulation. So as we talked about all these legal challenges because of this copyright infringement issues that are coming out due to those AI generated content, the European Union AI Act received the final approval in May of 2024 and established the world's first comprehensive legal framework for AI. This wasn't just another tech regulation, it was a blueprint of how society could harness AI's potential while protecting fundamental rights. And I read their white paper. It's quite long, but there are quite a few exceptions which are quite unnerving, but other than the exceptions, it's quite comprehensive. But what it has done, the Act's risk-based approach proved particularly innovative. The high-risk AI applications, such as those used in critical infrastructure or law enforcement, face strict requirements for transparency and human oversight. Like, people have to reveal an audit trail of how they're training their model, where the data is coming from, how they're using their human feedback. Is there human value alignment? Is there moral alignment? Are they using RLHF for aligning their AI models towards human values, for society's values, or not? So meanwhile, low risk applications, they are enjoying a lighter regulatory touch, encouraging innovation while maintaining basic safety standards. So the legislation also introduced mandatory impact assessment for high risk systems and requiring clear labeling of AI generated content, which is of course a direct response to the challenges posed by the increasingly realistic media generated by the AI. So what made the EU AI Act truly remarkable was its global impact. Major tech companies, Google, OpenAI, everyone began aligning their development practices with these regulations, effectively making EU standards the de facto global benchmark for AI development. In fact, anywhere you work, they will have a compliance office which will enforce these EU regulations. If your company does business in EU, you do have to comply with these regulations. You can totally geo-block EU if you don't want to follow those regulations, but if you serve any customer in EU, then your AI models must abide by those AI regulations. So the Act's influence extends beyond Europe, though. So it's inspiring similar legislative efforts in other places and jurisdiction, and is setting the stage for an international AI governance framework. Now, that being said, many people have said that this regulation has only stifled innovation in the European Union because there are so many regulatory compliance brings with it any kind of compliance burden, and this compliance burden can be substantially cost prohibitive for many enterprise applications. For example, if there is a late stage startup who suddenly gets hit with these regulatory requirements and they have almost running out of funds, and the regulatory requirements itself may cause them to go bankrupt, then the startup cannot bring their product to market because they're going bankrupt, because just following these regulations is totally depleting their funds. So there are pros and cons, and the EU is kind of will have a little bit of regulatory bottleneck when it comes to AI regulations and AI innovations, but other countries don't have such strict AI regulations. So if someone has a business in EU, so they have two choices: either comply with the EU regulations, or they can totally geo-block the entire continent and do not serve that population their systems at all. I mean, it's a decision that we have to balance. How much revenue are you going to lose compared to how much you stand to gain if you comply with the regulation. Let's say your cost of compliance is, let's say, $1 million, and you only lose $200,000 in revenue if you geo-block and shut off EU and serving in EU. Then there is absolutely no business incentive to comply with the regulations. It's better to just geo-block it. And but that being said, almost all countries will eventually have these. So if it's a mid-sized company, it's better to just start building those compliance pipelines, because it's cost prohibitive now, but eventually it will amortize and pay off. But for a startup, in an early or late stage startup, they might not generate enough revenue from Europe to spend too much money on these compliance requirements, but the investors might force them to do it. So it's a complicated scenario that we don't want to get into. So let's look at another breakthrough that happened in May. Important breakthrough that happened in May was YOLO, You Only Look Once, version 10 came out. This version merged its own previous YOLO architecture with the DETR architecture, the detection transformer architecture, which is mostly used for object detection and image segmentation. So the image segmentation usually is a very time consuming and resource consuming activity. So the earlier versions couldn't do the image segmentation in real time, which means they cannot perform image segmentation 25 frames per second on a consumer level GPU. But with the new versions, they can not only do real time object detection with 25 frames per second on a consumer grade GPU with, let's say, only 12 to 16 gigabytes of GB of RAM. It can even perform segmentation. The model has substantially improved. So as we see, and we have seen this before in computers, it's not just the hardware that catches up, it's the software also gets more efficient over time. And this is an example where the software gets so efficient that previously, when the object detection could only be done not in real time, but in it will take 1 or 2 hours to perform object detection. Now we have come to a point where we can perform real-time object detection on videos. So this is insane. In fact, it's already implemented in many other countries, and they're using it for traffic surveillance. So for example, in China, if someone violates the traffic, their pictures are taken in real time and displayed on big screen just to publicly shame them. So instead of finding them, I think they found this is a better way to prevent traffic violations, public shaming. So a lot happened in May, and let's move on to June and let's see what happened in June. June 2024 marked a transformative period in artificial intelligence, with Apple entering the AI game with Apple Intelligence, which represented a strategic shift in how AI is integrating with consumer technology. So they integrated ChatGPT natively across the Apple's entire ecosystem, from iOS devices to macOS and watchOS, fundamentally altering user interaction patterns. The system's sophisticated context awareness allowed it to generate comprehensive email responses with the touch of a button, create personalized travel itineraries, and provide proactive assistance across many applications. Apple's approach to privacy and learning proved particularly innovative. Instead of sending user data to central servers, each device learned from its user's behavior while keeping all the personal information local. The system only shared anonymous improvements back to Apple's servers. So imagine there is a local model, small language model that's learning on the edge device on your phone, and it's whatever its training weights, it's only sending those training weights and not sending the data at all, and which allowed the AI to become smarter collectively without compromising individual privacy. Think of it as millions of devices working together like a distributed research team, each contributing insights while keeping their sources confidential. When your iPhone suggests a better way to phrase an email, or your Apple Watch recommends a new running route, it's drawing from this collective intelligence while maintaining personal data private. This clever balance between personalization and privacy has established a new standard for AI training, AI integration into consumer electronics, and effectively mainstreaming the advanced AI capability for millions of users globally. So this training method where you learn in a federated manner over multiple millions of users without actually consuming the user's data is called federated learning, and that Apple has been pushing it for a while now. Also in June, remarkable breakthroughs were made in AI to predict Alzheimer's progression with astonishing accuracy, up to 6 years before traditional diagnostic methods. Leveraging advanced speech analysis, these AI models could detect subtle indicators of cognitive decline simply by analyzing short audio recordings. This approach provides a non-invasive and highly cost-effective screening method that could revolutionize early detection. The implications for healthcare are profound. Early detection of Alzheimer's significantly improves treatment efficacy and patient outcomes. By identifying subtle markers of cognitive decline even before the conventional methods, these AI tools will allow the healthcare providers to implement those proactive preventative interventions that can initiate treatment and help managing the progression of disease much better. This early action has the potential to drastically improve prognosis and quality of life for the patients. So what's especially exciting is how accessible this technology could be. A simple smartphone equipped with these AI capabilities could be used to screen for changes in speech and voice patterns, making this innovation easily deployable at home. Beyond Alzheimer's, these speech models are being applied to detect early signs of other neurodegenerative diseases such as Parkinson's, and this is kind of new. Parkinson's disease diagnostic models are kind of new and coming out now, but these were in the works for a while. This breakthrough empowers healthcare providers to implement more effective monitoring protocols and opens the door to widespread, early and accessible screening for millions of people. Millions of people suffer from Alzheimer's and early onset Alzheimer's and Parkinson's and other neurodegenerative devices. And as someone whose grandparents suffered from Alzheimer's and dementia, this advancement feels deeply personal. Early detection could transform the lives of countless families, and don't get me wrong, it's bad for the patients, and it's even bad for the families who are taking care of those people with Alzheimer's or dementia or other neurodegenerative diseases, because to see your loved one fade away in front of your eyes is heartbreaking and is difficult to cope with and produces tremendous amount of mental stress on the people around these patients. And these AI models, these early detections with these AI models will definitely be something to look forward to, and this is a tremendous development. No medication, nothing. The only thing that helps Alzheimer's, dementia and Parkinson's is early detection, because those amyloid plaques that forms in the brain, that can only be stopped when there's early detection. If they're already formed, then it's hard to unplug. Think of it, if there is pasting something with glue, and if it's once glued, it's hard to peel the glue off. And of course they're glue dissolvers and they don't work very well. Of course there is a new FDA drug which is approved by FDA, which is assuming to be great with Parkinson's, but all of these have some kind of side effect or other. Early detection is the best. Prevention is better than cure, always. These breakthroughs in AI-driven healthcare represent a significant step forward in improving how we diagnose and treat neurodegenerative diseases. As we looked at, June just keeps on giving. The open source community made significant strides with Nomic AI's release of GPT-4All. This project represented a fundamental shift in AI accessibility, offering locally deployable language models that rivals the capability of the proprietary system, ChatGPT, Claude, and all those. GPT-4All eliminated traditional barriers to advanced AI implementation. Before that, we have to locally pull those GGUF models, or the best we could have done was use the Ollama's chat interface and spin up a GUI front end and access those back-end server of Ollama server running in the background and serving those large language model. Or we could use the text-based Ollama chat interface. So this was a substantial improvement. This is a simple, easy to install front end which streamlines the whole process of using the large language models locally. All anyone has to do is install this. It's very simple to install. It's available for multiple different platforms. It is available for Linux, it's available for Windows and Mac OS. All anyone has to do is install it and run it, and that's done. Then it will automatically suggest which language model to install. In fact, it has a repository of language models you can install depending on your GPU VRAM. You can use those. In fact, it can also use CPU RAM, but it will be slightly slower in inferencing capabilities, and it can definitely use multimodal capabilities. You can dump pictures, upload pictures, and start chatting. You can add documents and start chatting with them in a RAG fashion. It implements vector databases automatically locally, so we don't have to worry about implementing those RAG architecture, and it abstracts away all those things and presents a simple to use GUI architecture. This is very interesting. This is amazing. And if you have not used GPT-4All, again, I encourage you to go start using it. If you have a GPU, definitely you should be using this. It helps us contain all those personal information in an air-gapped fashion. If you are interacting with certain documents like your tax documents, you don't want to paste your tax document into ChatGPT and ask questions. It's better to use your local model. Dump your tax documents in your local model and then interact with your tax document and ask what was the last year taxes and etc. Whatever questions you have, like how much or what deductions did you take last year, or what was your IRA contribution. If you don't want to go through all those documents, just dump that. This is a great use case to interact with your tax documents. And if you don't want to release, some people are comfortable dumping their tax documents onto ChatGPT, but I am not. I rather use that. And if you're like me, I suggest you give GPT-4All a try. July 2024 marked several pivotal developments in AI, with Meta's release of Llama 3.1, which is a substantial development for the open source revolution. This iteration of Llama achieved remarkable advances in both scale and functionality and established new standards for the large language model. The most significant enhancement in Llama 3.1 was its expanded context length, increasing from 8,000 tokens in Llama 3 to 128,000 tokens in Llama 3.1. That was a drastic expansion, which allowed the model to process and analyze entire books or comprehensive research papers in a single pass while maintaining contextual understanding throughout. For enterprise application, this meant the ability to analyze extensive documentation, while researchers could process entire academic papers with preserved context. And Llama 3.1 has now come into on par with Anthropic's Claude in terms of its context length. Llama 3.1's enhanced reasoning capabilities demonstrated marked improvement in logical analysis and problem solving. The model exhibited sophisticated understanding of complex queries, making it really valuable for research and advanced computational tasks. These improvements, combined with optimized processing architecture, resulted in significantly reduced latency for real-time applications. July also witnessed the introduction of Coastral Mamba by Mistral AI. It represents a fundamental advancement in code generation analysis. The system's innovation lies in its SSST4 architecture, known as the Mamba architecture, which is how reimagined how AI processes and generates code. Is a complete departure from the transformers-based architecture of the large language model. This is a new architecture. In fact, Mamba's state space model architecture marked a departure from traditional transformer-based approaches. While conventional language models process information sequentially, this Mamba architecture implemented a relationship-focused analysis system. So this architectural shift allowed more efficient processing of code structure and logical relationship. So the practical applications of this approach proved substantial. It is extremely efficient in analyzing code relationship and results in improved performance across all benchmarks and metrics. So now this Coastral model are not as good as generating code as the Anthropic Claude models or GPT-4 models, and the reason being those models, GPT-4 and GPT-4o and the Claude Haiku models, are substantially larger. This CodeStar model is really small. It's probably only 50 billion parameters, less than 70 billion parameters. These small models will never be as good as generating quality code. The only problem is that there is probably not enough funding for this open source model to be scaled up to those sizes. So imagine these models are generating almost high quality code at a level almost slightly less quality than GPT-4. Imagine when these models are scaled up to the size of GPT-4, what these models can do. They can completely replace human coders in their coding efficacy and efficiency. So that being said, there is more funding going into these. So, and if we are interested, if you are a developer, you should get engaged and start contributing to these platforms and help scale up these open source model and make them better for code generation. So CodeStral is the only Mamba model that is deployed by Mistral AI. The other models that are deployed by Mistral, which is the Mixtral, which is the mixture of experts model, and this is was quite famous in around December 2023 because it outperformed even GPT 3.5 in certain tasks. So that being said, they are not actively producing more models, and I'm guessing due to the EU regulations in place, but they will probably come up with something much better sooner, but fingers crossed. In the creative domain, July witnessed a significant shift in generative AI capabilities, and we talked about this. This was the summer of text-to-image models, and this is where it got really good with the simultaneous release of Flux's AI image generator and Auraflow from FAL. So while both models initially appeared as competitors, Flux quickly established itself as the superior solution, particularly in anatomically accurate image generation. This is something we talked about. Stable Diffusion suffered from this flaw. Stable Diffusion generated extra limbs, extra hands, extra fingers. Their generated models were not anatomically accurate most of the time. So one thing that became popular in the image generation community, AI art community, is that the need for including a negative prompt. In addition to the regular prompt where it's like generate me the image of someone walking on the beach, you also have to add a negative prompt. No more legs, no extra hands, all those things. Those are negative prompts which prevents from the model from generating those extra anatomical features. Flux completely bypassed all that. In fact, addition of a negative prompt to a Flux image generator is no longer required. So in Auraflow, even though it worked really well initially, Flux totally blew it out of the water. Flux demonstrated unprecedented capabilities in text generation within images as well, a feature that Stable Diffusion only implemented in recent versions. Flux's technical sophistication comes with a price though. Initially, the model was so large that it couldn't fit in a consumer-grade GPU. However, the development community soon rapidly addressed this limitation through innovative optimization techniques. Their solutions involve separating the VAE, the variational autoencoder, and the clip encoder component, which are usually fused along with the generator, and they separated that separately. And the reason is these two models were not part of the Flux architecture itself, so they could, but just by separating these three components, the text encoder, which encodes the text into latent, and then the final image generation, the VA, which performs the image generation from those latent encoded generated image, the community was able to bring down the memory footprint substantially. And on top of that, the community also quantize the Flux model itself, and quantization is a process where the memory requirements are shrunk substantially. It turns out that there is not too much effect on the image generation capability of the model if the model is quantized substantially, and that gave a huge boost to the consumer market, where all the open source community can use quantized models which can fit on a 12 GB GPU, and dramatically expanded its accessibility to regular users. This technical achievement, combining superior generation capabilities with practical hardware requirements, fundamentally transformed the landscape of AI-powered content creation. Now everyone can generate AI images, and become a social media marketer, for example. Meanwhile, Auraflow contributed to the field through its innovative large rectified flow architecture. So that's a completely different architecture than the diffusion architecture that Flux and Stable Diffusion uses, though its impact is kind of more muted compared to Flux's transformative capabilities. So these developments collectively represented a substantial evolution in artificial intelligence capabilities, from enhanced language modeling to sophisticated code generation and creative tools. July 2024 demonstrated the accelerating pace of AI innovation, and I don't say it lightly, it was truly accelerating at that point. It's like the singularity is hit and the exponential graph is moving upwards. And as we look at it, so these advantages are not only in expanded technical capabilities, but also making sophisticated AI tools more accessible to developers, researchers, and creative professionals worldwide. August 2024 will be remembered as the month when text-to-video tools truly came of age, with the simultaneous release of groundbreaking platforms like Runway Gen 3, Luma's Dream Machine, Kling AI, Hyper. The world entered a new era of creative expression and storytelling. These tools didn't just raise the bar, they redefined what was possible. Now we are waiting for text-to-video models for a while, and now they have arrived, and making it easier than ever to transform ideas into stunning visual narratives. So let's start with Runway Gen 3, where they have like substantial advancements in text-to-video models. Runway introduced Gen 3, the third iteration of its AI video generation model, and it was nothing short of spectacular. This model delivered high-quality visuals with unmatched realism and reduced artifacts, those broken pieces of tearing of the video that happens when it's generated by an AI model. And it produced video content that can seamlessly blend into professional productions. And the best part is Gen 3's rendering speeds were lightning fast, allowing creators to iterate on ideas in real time. For short films to marketing campaigns, Gen 3 became the go-to tool for anyone looking to produce polished video content without the need for extensive production resources. Luma Labs launched Dream Machine right after that, and it is an AI capable of generating both text-to-video and image-to-video content. Image-to-video content is substantially harder because the image needs to be compressed and the latent representation needs to be extracted before it can be used to produce the video content. Also, alignment is difficult. With text-to-video, the AI model can think and make something similar closer to the prompt, but image, you cannot get away from the image. Image is where its starting point is. It needs to match it exactly, so it's much harder. So what set the Dream Machine apart was this versatility that users could upload an image and watch as the AI extrapolated into dynamic video sequence. So this was big. While it didn't quite match the visual fidelity of the Runway Gen 3 or Kling, Dream Machine's user friendliness and flexibility made it a favorite among creatives who are exploring new ways to tell their stories. It became a tool of not just for professionals, but for hobbyists and educators looking to experiment with video creation. If Runway Gen 3 was about speed and realism, Kling AI was about precision and control. Released by a Chinese company, Kling introduced an innovative feature called the motion brush, allowing users to define specific movements with their generated videos. So they can do a motion brush and it will follow like a cat. You can trace a cat sitting on a wall and trace a line along which it can jump, and the cat will jump along that line, and it will create a video that the cat jumps along that line, and the video will be realistic with physics and everything, with the gravity acting in the right direction. So cat will not fly upwards, it will fall downwards in the correct projectile pattern. So this gave creators an unprecedented level of customization, making Kling the ideal tool for filmmakers, animators, and brands looking to produce cinematic quality content. The last one we'll discuss in the text-to-video generation models that were released in August of 2024 is Hyper. While Hyper didn't boast the same level of polish as its competitors, it did earn its place by being incredibly accessible with a simple interface and focus on democratizing video generation. Hyper allowed a wider audience, including students, small businesses, and independent creators, to explore the possibilities of AI-generated video. August was a month of revolution in text-to-video generation. The release of tools like Runway, Luma, Dream Machine, Kling, Hyper made it clear that the future of storytelling is here and it's powered by AI. Whether you're a filmmaker, marketer, educator, or hobbyist, these platforms open up new worlds of creative possibilities, democratizing access to high-quality video production. As we move into September, the focus shifts to cutting-edge advances in AI architecture and the tools that are reshaping how we approach complex problem solving. Let's talk about that. October 2024 was a month with foundational advancements in AI architecture, with NVIDIA entering the AI race in a big way. They released their Nemotron series of models and open up cloud architecture for people to use. Previously, the only available cloud architecture to host machine learning pipelines or LLM pipelines for LLM inferencing were the ones that are provided by OpenAI, Azure, AWS, GCP, which has those tool calling capabilities to OpenAI and Claude. You can start directly using those cutting edge NVIDIA processors, NVIDIA GPUs on their cloud platform. And this is a great, brilliant business move by NVIDIA by opening up and starting on one of their own cloud architecture. They are going to be light years ahead of AWS, GCP, and other cloud providers because they have a monopoly on the CUDA processors themselves. So instead of selling to AWS, they can just stock up and provide those latest hardware to their own cloud platform. Yes, it can mess with the anti-monopoly laws, but eventually they are allowed to do that. They can host their own cutting-edge processors and block access to those processors, to those GPUs, to the other cloud providers, essentially creating a monopoly to NVIDIA. And people will start, those, especially the enterprise clients, will start using those because they are resource hungry. Imagine anyone who wants those NVIDIA processors for LLM inferencing. Whoever is hosting their large models, they want to use that NVIDIA's cloud architecture to host their models. So in this event, they also released their other Nemotron series of models. And specifically, they released a filtered model, digital model called the Minitron 8 billion. It is a next generation foundational model designed to deliver unparalleled accuracy and efficiency. It's great because it's a distilled model. It's not a big model, it's a small model, but the small models do perform poorly. But this model is produced by distilling and pruning a very large model. Distillation is a very advanced technique where a large model, all the knowledge from the large model is distilled into a smaller model, essentially making it highly capable or having as much capability as the larger model with less amount of training and memory overhead. In the same vein, talking about AI infrastructure, RoboFlow, a leader in computer vision tools, launched its inference AI platform in this month, and it brought unprecedented ease and power of deploying AI vision models. Previously, AI vision, if we want to, let's say, identify events and track objects real time, or even not even real time, just track objects, and if that's one of our use cases, then we have to create extensive pipelines, use YOLO, and if we're doing enterprise architecture, and we also follow audit trails and regulatory compliance, and we have to build all of that. So this model, this platform that is built by RoboFlow, allowed developers to take trained models and run them in real-world applications with minimal setup and with maximum efficiency. Whether you're working on object detection for autonomous vehicles or facial recognition for security system, RoboFlow's platform delivered unmatched performance. It totally streamlined inference and enabled rapid deployment. Essentially, we don't have to worry about the architecture, what I call the plumbing. We don't have to worry about how to connect Kinesis models where the stream data is coming to our S3 to store the data, and then the ingestion pipeline and using Bedrock to run those inferencing. I'm talking about the AWS cloud architecture, all the plumbing that's required on AWS. It will be extensive. It will take multiple engineers, many hours of working on building that architecture, the entire pipeline, just to detect a few events. A specific use case might be, maybe you are, let's say, a media management company where you essentially run ads when there is an event occurs. Let's say you are looking at a soccer match and a goal happened, a goal is scored, and then you have to run ads right after that. So you have to detect a goal is happened is scored in an automated fashion by your machine learning, which is essentially a real-time object detection model like YELLO or DETR. Then you're running that pipeline, and then you're going to run after that when the pipeline detects an event like a goal has been scored. So if you have to build the architecture yourself, a lot of plumbing is required, a lot of engineers are required to build that entire pipeline. With RoboFlow inference, you have to make sure the objects is directly streamed and it quickly gets an inference directly from their architecture. That's pretty neat. So generative AI continued to evolve in October, and mostly we are seeing major advancements in the architecture, in the operationalization of those AI models that have been built so far. And it built on the excitement of the earlier months, and the companies worked on refining their models to provide more user control, better consistency, and higher quality outputs. While all these updates didn't introduce entirely new tools, the focus was on usability and efficiency, and it showed how quickly this field is maturing. The biggest story in October was the Optimus robots. This is the robot which was released by Tesla, and Elon Musk introduced them as a humanoid robot that can perform household chores like folding laundry and doing other household chores like cutting vegetables, and can perform a human level interaction. And these are all powered by ChatGPT, and there are multiple videos floating around where you can see them interacting in a human-like fashion. Of course, it is powered by ChatGPT, but there are so many things that has been said about it already. I'm not going to go into that detail, but this is an exciting field. We are entering into the era of robotics. The era of robotics have started. This is another singularity point where we have seen the graph to move sharply upwards in an exponential fashion, where they will start seeing more humanoid robots, and will soon be bringing humanoid robots home. Maybe in 1 or 2 years, many people will have humanoid robots at home working for them, not as a slave but as a companion. Some people will use them as a companion, some people will use them as their helper, some people will use them as a butler. OpenAI made headlines in November of 2024 with the launch of o1, which is a groundbreaking model designed to tackle complex reasoning and decision-making tasks. While previous models of GPT-4o excelled in generating human-like responses and assisting with creativity, o1 took things to another level. It wasn't about understanding, it was about strategic thinking. o1 introduced a novel hierarchical reasoning framework that allowed the model to break down complex problems into smaller, manageable components, the way human beings perform task completion. And imagine asking it for business strategies or scientific research insights. It will not only just provide information, it will map out actionable plans tailored to the query. This made o1 a powerful tool for enterprises, researchers, and even individual users. But frankly speaking, I found o1 a little bit underwhelming, because even with this advanced reasoning capabilities, it's quite slow in giving responses, and most of the time I'm not looking for it to plan out things for me. I mean, I don't have that use case. I just want a quick answer. So GPT-4o is sufficient. So what truly set o1 apart, in my opinion, is its ability to integrate tool calling functionalities. Tool calling was embedded in it, and it can query specialized API like Wolfram Alpha and run simulations and generate visual aids in real time. You can upload a CSV and it can generate a Python code, and then it can do a tool call and run the Python code in the code interpreter and get the results and display the plots. And so for me, that was the big thing. The tool calling functionality is amazing, but you know what, Llama 3.2 also has that capability. But so o1 is not such a big deal as much as people say, but it has its uses in enterprise grade use cases. As we close out 2024, December brought us a flurry of updates that polished existing technology while setting the stage for what's to come. From enhanced language models to advancements in structured outputs and editing tools, this month was a celebration of AI's growing maturity. So let's start talking about Llama 3.3. This is the third iteration of the Llama 3 models. What it made it a standout moment in this month is this Llama 3.3, which is a 70 billion instruction tuned model, but it is only a text only model. But despite its smaller size compared to its predecessors like Llama 3.2 and Llama 3.1 and even Llama 3, Llama 3.3 offered unprecedented efficiency and accuracy for text only applications, though it's not multimodal. So the whole point of Llama 3 is that even though it's only 70 billion parameters, it matches the accuracy and performance of the 405 Llama 3 model, the original 405 massive model, Llama 3.1 model. And when it's run on the Grok, and Grok has demonstrated that using Llama 3.3 you can write an entire book in seconds, and it can solve the apparent strawberry problem in 1.48 seconds, and it can even use Wolfram Alpha to calculate the square root of complex equations in seconds. So all of those it can do reasoning tasks, it can perform tool calling, it has all those. Even though it's only text only, it matches the performance of the 405 billion model. But that being said, the 70 billion model still needs around 60 to 65 gigabytes of GPU RAM, so it cannot be run on a consumer grade GPU. So local users who use Llama locally, it's still out of reach for them. But if they can afford a bigger GPU architecture, or if they want to rent an online system like Grok or FalAI or Val or whichever one they prefer, if they rent an online GPU and run the inference pipelines there, then I guess they can take advantage of this model. But all in all, it's amazing that Meta was able to distill the knowledge of the 405 billion model into a 70 billion model. This is amazing work. Has released a very new recent model to watermark images, and I think this is one of the best releases that came to hit the AI market in recent months. As misinformation continues to pose challenges, Meta's FAIR, the Facebook AI Research Division, has introduced a model which is capable of embedding invisible watermarks into AI generated media. And this is important because Facebook is replete with these kind of fake content and Facebook has been struggling with that. They have machine learning models that they just deployed to identify these fake images and fake content, and they have been battling misinformation and disinformation on their platform for years, maybe over a decade now. And this is the latest in their arsenal that they're deploying to the market. Not only will it help in identifying AI generated content, it will also help copyright claims, and it will also help AI artists to watermark their images so that they can pursue any kind of infringement of their copyrights. So these watermarks are imperceptible to humans, but they can be detected by AI tools, which makes it easier to verify the authenticity of the content and of course track its origin. This innovation is a crucial step in managing the proliferation of synthetic media, and it provides a safeguard against the misuse of AI for disinformation campaigns while enabling legitimate creators to maintain transparency. It's another reminder that as AI grows more powerful, so must its safeguards. If you have ever tried to use Ollama for local AI development, you probably know how frustrating it can be when Llama-based models refuse to respect the pedantic constraints. Or in other words, if your output needs to follow a specific format like name, John Smith, alumni, ASU, there's a good chance the model won't return it in that way. Instead, it might provide a loosely formatted response, like it can just say John Smith who went to ASU. Adds unnecessary context, and which breaks all the AI agents which are working on this output run downstream. So if you have a crew of AI agents working in tandem, so let's say you are scraping people's name from their alumni database, and then you're creating a list of people who you can reach out and create a sales funnel. Because let's say you are working on an ed tech company and you're creating a sales funnel based on the alumni who went to a particular university, and you'll grab their one, you make an agent which can grab the list of alumni and scrape the list of alumni from the alumni website, and based on each alumni and each alumni affiliation, you can further do a LinkedIn search and then get the details into a CRM, which can then run the sales funnel. So in order to do this, there are a few steps. Each step is handled by an AI agent. The first AI agent scrapes the alumni website to get the information of the affiliations and the name, and it then passes on the alumni's name and details, name and affiliations in the correct format that we just said, name and then affiliation, downstream to the next agent, which uses that affiliation information to search on LinkedIn and find out more about that very specific individual and find out more about them, and then push that into a CRM. But the secondary agent cannot perform that task if they don't get that information in the correct format. So if you have written code before, then you'll know that you have to pass a function with the correct formatting. In function, that's pretty simple, but in LLM agentic method, everything is kind of loose. In order to constrain that, people use Pydantic constraints, very specific ways the output has to be formatted or the input has to be formatted. But however, Llama agent, especially running with the Ollama background, never respected that, and it all is a nightmare to run Creo AI models using these Ollama based Creo AI agents. So, but not anymore. In December of 2024, Ollama has introduced support for structured outputs, which allows developers to constrain a model's responses to a very specific format as defined by their what is known as JSON schemas. So with this update, Ollama's Python and JavaScript libraries now ensure that the language models produce outputs that are reliable, consistent, and perfectly tailored to downstream tasks. And why this matters for agentic workflows: structured outputs are a game changer for building agentic flows where AI systems rely on passing data between different agents. Consider this: if one AI agent is tasked with extracting key information from a document and sending it to another for future processing, the output format must be precise. But before this update, developers had to use workarounds like post-processing the model's responses. So if you get a response and it's not following the Pydantic schema, or if it's not following that exact format that you're expecting, you have to ingest it and format it by yourself, maybe using another LLM or maybe using your own regular expression method, which added a lot of complexity and reduced efficiency. So now Ollama eliminates this headache by enforcing strict adherence to the schema during the generation. This means parsing data from documents is clean and precise, extracting data from images is seamless, and responses follow defined formats without requiring additional validation or reformatting. This is amazing. This is very exciting about this update in its potential to propel these local agentic flows. Developers building AI-powered assistant, automated pipelines, or even custom enterprise tools can now rely on Ollama to handle the data parsing and formatting tasks with ease. For example, you can build a legal assistant, AI assistant, which can extract clauses from contracts and present them in a JSON array for review for another AI assistant to ingest, and they can finally write the report. Maybe you already have an AI assistant, but it's waiting for the OpenAI to give that data in a JSON format. You can just take that agent and plug it into a newly formatted legal assistant, which is now returning the data in JSON format. So it's like becomes a quick plug and play simple system. Or you can create a financial agent which can parse transaction details into a predefined formatting that can be ingested downstream by your automated trading bot. Or there you can have a research assistant which can organize structured data from multiple sources into consistent schema and then send it down to research. So if you have let's say a trading team who is performing research, now the trading bot can have a sub bot which can perform research. So the research bot can provide that data to the trading bot, but that communication can now be facilitated much more easily because the structs are there. Those plugins are now available. This improvement not only makes Ollama more competitive, but also lowers the barrier for creating reliable Agentic workflows are here, guys. It's going to dominate everything right now. What RAG did at the beginning of 2024, agentic workflows are going to do for at the beginning of 2025. Developers no longer need to compromise on output consistency or spend hours debugging all these formatting issues. Instead, they just can focus on innovation, knowing that all these backends will be handled smoothly. This update is a game changer, and it's a big news for the open source community. The world of image editing saw a leap forward with the release of FlowEdit, a tool which redefined text-based editing for pre-trained text-to-image models. Editing by inversion is essentially taking a target image. Let's say I want to take an image of a cat and transform it into that of a dog. A cat sitting on a wall, transform it into a dog sitting on a wall, or a tiger sitting in a wall. So in order to do that, we take the image of a cat, we invert the image of the cat into its latent representation, and then transform it and transform the latent version to the distribution that it's towards the dog. Okay, so this is like if you have seen word vectors. So if we take king and then we subtract male and then we add plus woman, so king minus man plus woman equals queen. So if we take a word vector, a numerical representation of the king, if it's pointing in certain direction, subtract maleness, and then added womanness to it, it will point in the direction of queen, or the word vector. So this is the numerical representation in the feature space of the idea of king or kingness and queenness. So that's the same idea with inversion. So we can take the idea of the image of a cat and represent its latent encoding, the way it's encoded in our brains or in any neural network, and then take the distribution and push it along the direction in which it represents dog, in latent representation of dog, and then invert it back. So that's changing editing images using text-based prompting using inversion. Now FlowEdit goes totally short circuits this, because these kind of latent inversions causes artifacts, because the cat might not exactly, a black cat might not exactly translate to a black dog, because that's what we want, or a black cat will not translate to a black panther. If we say that to take the image of a black cat and transform to that of cat, then the black cat usually goes to a black panther, but not always. Sometimes it can go to some other tiger. It might just go to a tiger. It might not go to a black panther. That's what we're expecting. So FlowEdit completely fixes that by doing those translations in the latent space in a very clever way using ordinary differential equation. I'll not go into the detail, but it does it in a much better way, and it is model agnostic, so it can do it for any kind of diffusion model, whether it's flux, stable diffusion, or aura flow. Any kind of diffusion, any kind of model, it can perform the same task. And that's a wrap for 2024. What an incredible year it has been for AI. One that pushed boundaries, solved problems we once thought was insurmountable. From the breakthroughs in generative media and text-to-video models to the leaps in healthcare AI and robotics, and the refined capabilities of these really huge large language models from Llama 3 to OpenAI's O1, we have seen all this innovation reshape what's possible. But let's not forget, these advancements are just the stepping stones. We are at the cusp of the exponential graph that is only going to exponentially increase. Every breakthrough this year has set the stage for even greater progress in 2025, a year that promises to bring new ways for AI to enrich our lives, empower creativity, and drive solutions to the world's most complex problems. Thank you for joining us throughout this journey. For your curiosity, your passion, and your insights. Your engagement is what makes this podcast so special. We are excited to dive into the next chapter with you, and we can't wait to see what the future holds. Wishing you all a joyful holiday season and a new year filled with innovation, inspiration, and growth. Until next time, take care, stay curious, and we will see you in 2025. That's a wrap for today's episode of Machine Learning Made Simple. If you have questions or want to explore AI topics further, please don't hesitate to leave a comment. Until next time, keep exploring and enjoy your AI adventure.